Hello, my name is Samuel Owiru Kamau. I'm an ML advisor at Kaggle and Kenyan. I've been working closely with Debridge Elimo, software engineer, intern at Axon, and Princeton University senior, my fellow Kenyan, to develop EmbedMind Studio. So what is the problem? There's been a hardware development complexity where building agents for embedded hardware demands deep knowledge in embedded system AI models and cloud integration simultaneously. A lot of hardware in the market being developed by different organizations such as Platform IO, they require some simultaneous expertise. So for you to integrate an agent together with the embedded system, whether it's a sensor, a microcontroller, etc. Our solution is to create a unified AI agent builder for embedded hardware by providing an all-in-one IDE where you can deploy agents in that Wi-Fi enabled module that you have, whether it's Raspberry Pi or ESP8266 at the moment. Then from there, you can make sensor simulations and also get actuator action from the agent. Our solution is basically having the microcontroller sending inputs to the Embed Studio, where you define now the tool and configure any safety settings, hence building your agent. After which the agent responds to control the actuator, e.g. a fan or a motor. Our technical architecture is pretty simple, where we have Streamlit as our front end. Then it communicates with the microcontroller using Flask API. After getting input, it takes the input to the agent. Then the agent does the action, then sends the output to the microcontroller. As you can see, there's also a simulator, as you're going to also see. For a demo, we'll do a fire detection and response system where we have the ESP8266 Wi-Fi module, as you can see. Then we also have the smoke sensor that will act as the sensor, and the ventilation actuator, which is a fan that will act as our actuator. So this is our Streamlit app, where I can define the project name, which is a fire safety agent. Then I select our Wi-Fi module, which is the ESP8266. I configure the server URL, currently running on the local host. Then the LLM provider, mine be Gemini. Then I enter the API key, which is currently embedded, and the sensor configuration, which is the smoke. From there, I can run and find also incoming data packets coming directly from the ESP. So you can see the first data packet, which indicates a smoke value of 36 parts per million, continues up to the 10th packet, which still is 36 parts per million, then the timestamp. Then I write my agent. So my tool is given a smoke reading of this, should we activate the motor, ventilation, and warning LED, then return exactly this format, motor on and off, LED on and off. Then the response is being generated, and it returns that value, whether it's on or off. Then you can run your simulation to see what values you'll get. So the agent output will be motor on and off. Then the output sent to the hardware would be the LED off, motor on. And from my side, you can also tell that the motor is off or on. This changes depending on your input. Again, if you put, if the sensor records a high value of smoke, it's going to turn on both actuators. For this case, would be the LED and the motor. Then you can save and also download your solution. Thank you.